Welcome friends. In this module we discuss classification and tabulation. Classification. Classification is the arrangement of collected information into homogeneous classes or groups. Classification of the data is made according to the nature and purpose of the data. For example, the data on households can be classified according to religion, income, education, etc. The marks of some students can be classified into distinction, first class, second class, etc. Objectives of classification. Objectives of classification are 1. To reduce the complexity of the data. During classification, unwanted details are eliminated and the data are arranged in an ordered, simple and approachable manner. 2. To compare the collected information. Classification helps to compare the data collected. For example, the data on the attack of a particular disease in a state, the district level classification of the data helps health department to compare the rate of attack of the disease among districts and to introduce more effective remedial measures. 3. To bring out the relationship between the variables. The relation between the variables included in the data can bring out by classifying the data. For example, the characteristics, types of medicine and the days required to cure a particular disease can be related. To extract their relationship, classification of data is needed. 4. To convene tabulation. Only classified data can be tabulated. Hence, data classification is essential for tabulation, etc. Properties of an ideal classification. 1. Exhaustiveness. All the classes should be clearly defined and each and every observation must belong to one of the classes. 2. Mutually exclusiveness. No observation belongs to more than one class, otherwise classes must not overlap. If so, it will make some ambiguity. 3. Stability. The classification once made should be capable for any statistical inquiry which is having a possibility to arise from the data. 4. Homogeneity. The classes created should contain homogeneous items, otherwise subclasses also to be made. For example, classification basis on employed and unemployed groups may need a further classification according to education level for further homogeneity. 6. Flexibility. No classification will remain forever. Classification should be flexible to accommodate the new and changed situations and conditions. Types of classification. Depending upon the nature and purpose of the data collected, it can classify in various types. Following are the common forms of data classification. 1. Geographical classification. 2. Chronological classification. 3. Qualitative classification. And 4. Quantitative classification. 1. Geographical classification. This is based on the geographical areas from where the data is collected. For example, a data on the sale of a particular commodity need to be classified according to the areas of sale for identifying the sale volume of various geographical areas. Here, the classification of the sale data may be classified according to state, district or village, etc. 2. Chronological classification. Here, data are classified according to the time of its occurrence. Data regarding import and export of a company or the data regarding the attack of a particular disease may be classified according to year to identify the rate of the corresponding event from year to year. 3. Qualitative classification. When the data are classified according to characteristics which are not possible to numerically measurable like beauty, intelligence, etc., the classification is called qualitative classification. 4. Quantitative classification. If the data are classified according to some quantitative measurements like height, weight, marks obtained in an examination, etc., the classification is quantitative classification. The quantitative phenomenon under consideration is called variable. The variable may be discrete or continuous. If the possible values of a variable are finite or countable, the variable is said to be discrete. Otherwise, if the variable can assume any real number within certain limits as its value, the variable is a continuous variable. For example, variables denoting number of children in a family, number of attacks of asthma per week are discrete, and the variables such as height, which take any value within a given range, are continuous. Frequency distribution. Frequency distribution is the orderly arrangement of the data classified according to the values of the variable. Two kinds of frequency distribution are 1. Ungrouped frequency distribution and 2. Grouped frequency distribution. Ungrouped frequency table is a representation of the collected data in the form of two columns, where one column contains values of the variable and the next column contains the number of times each value repeated, which is called frequency of that value in the set of collected data. To create an ungrouped frequency table using the given data, first we list the collected values in ascending order of magnitude and then reading the data one by one and put tally marks against the listed values. In final, count the tally mark of each value, which is recorded as the frequency of that value. For example, consider the following data on the number of children in 20 families of a town: 0, 1, 2, 1, 0, 3, 1, 2, 3, 3, 2, 2, 1, 1, 0, 3, 2, 1, 2 and 3. An ungrouped frequency table representation of the data is as follows: number of children 0, 1, 2 and 3, and then tally marks are entered. Counting the tally marks, frequency of each values: for 0 it is 3, for 1 it is 6, for 2 it is 6 and for 3 it is 5. In common, the values of a discrete variable are represented in an ungrouped frequency table and that of continuous variable are presented in grouped frequency table. The method is as follows. Consider the continuous variable height of 100 students. The data can be classified into different classes or groups of heights, say 100 to 110 centimeters, 110 to 120 centimeters, etc. Then the number of students with height belonging to each of the classes are counted and noted against each class, which are called frequency of that class. Various steps involved in constructing frequency distribution table are as follows. 1. Finding the least and highest value of the variable. Identify the largest and smallest observation in the given data set and their difference is called range is to be found. 2. Determine the number of classes. Normally, a frequency distribution not containing more than 20 classes and not less than 6 classes. Even though there is no hard and fast rule regarding the number of classes, M.A. Sturgis suggested a formula to find the number of classes for the data. According to his suggestion, number of classes equal to 1 plus 3.22 log n to the base 10, where n is the total frequency. 3. Deciding the class interval. Magnitude or sizes of the class interval are commonly kept uniform and it is founded by dividing the range of the data with the suggested number of classes and round off. 4. Counting values belonging to each of the classes. Reading the data one by one and put tally mark in the class where the red observation is coming. In final, count the tally mark of each class, which is the frequency of that class. The two methods for forming class intervals are 1 exclusive method and 2 inclusive method. In exclusive method, class intervals are fixed in such a way that the upper limit of a class is same to the lower limit of the next class. For example, the classes are of the form 0 to 10, 10 to 20, 20 to 30, etc. are coming under exclusive classes. In such a classification, the observation 20 is included in the class 20 to 30 and this observation is excluded from the class 10 to 20. In inclusive method of classes, the lower limit of a class is the next value of the upper limit of the preceding class. Following are the classes coming under inclusive method: 0 to 9, 10 to 19, 20 to 29, etc. In some situations, classification is done with first class not closed at the beginning and the last class not closed at the end. For example, the classes in such classification may be as below 10, 10 to 20, 20 to 30, etc., 50 and above. This type of classification is the classification with open-ended classes. Frequency density of a class is the class frequency per unit magnitude of the class. It is obtained as class frequency divided by class width. Relative frequency of a class is the ratio of class frequency to the total frequency, and the percentage frequency is the expression of class frequency as a percentage of the total frequency, which is expressed as class frequency divided by total frequency into 100. Cumulative frequency distribution. Cumulative frequency distribution gives successively added or subtracted frequencies up to each of the classes. In a less than cumulative frequency distribution, the total frequency of all classes less than and equal to the each of the class is listed. In a greater than cumulative frequency distribution, the total frequency of all classes greater than and equal to the each of the classes is listed. As an illustration, consider the following frequency distribution: class 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. Corresponding frequencies 5, 8, 13, 10, 9 and 5. In a less than cumulative frequency distribution, the cumulative frequencies are as given as follows: classes 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. Corresponding less than frequencies 5, 13, 26, 36, 45 and 50. And in a greater than cumulative frequency distribution, the cumulative frequencies are as given as follows: classes 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. The corresponding greater than frequencies 50, 45, 37, 24, 14 and 5. Tabulation. Tabulation may be defined as the logical and systematic organization of statistical data in rows and columns. It facilitates the analysis of the data. Tabulation is an intermediate process between collection and statistical analysis of the data. Main objectives of the tabulation includes: 1. To clarify the object of investigation, 2. To simplify complex data, 3. To depict trend, 4. To save space and 5. To facilitate comparison of the data, etc. An ideal table should contain as information as possible in a specified space with no loss of clarity. Main parts of a statistical table include: 1. Table number. To enable easy reference of a table, it should be properly numbered. 2. Title. An appropriate, clear and precise title which explains where the data are, what the data are, when the data occurred and how the data are classified is to be given for every table. 3. Caption. Captions are column headings which indicate what the column represents. Each column should have captions. 4. Steps. Steps are row headings which indicate what the row represents. Each row should have steps. 5. Body. Body is the main part of a table, contains the collected numerical information. 6. Prefatory notes and footnotes. Prefatory notes are given just below the main heading. This is for explaining those which are not cleared by main title. For example, prefatory notes can be included to indicate the units in which the data are expressed in the table. Footnotes are added below the body of the table to clarify or to give explanation for any item included in the table if necessary. 7. Source data. Source data refers to the source from which the data has been collected. Format of a table with the suggested parts is as follows. Types of tables. Different types of tabular representations of data according to the nature, aim, objective and scope of the survey are: 1. Simple and complex table. 2. General and special purpose table. 3. Original and derivative table. 1. Simple and complex table. When the data represents according to only one characteristic, the table is called a simple table. For example, in a health survey, the heights of people participated are listed in a simple table as follows: height distribution of people, heights in centimeters, less than 100, 100 to 120, 120 to 140, 140 to 160, 160 to 180 and more than 180. Number of people 2, 13, 22, 38, 17 and 6. If the table is made considering two or more characteristics simultaneously, then it is called a complex or manifold table. For example, in a health survey, if we record the height, age and sex of people simultaneously in a table, the table is a complex table. Let us make such a table as follows. General and special purpose table. General purpose table, which also called repository table, represents the raw data in great detail, covers variety of information on the same subject and represents the data without any special analytical purpose. Special purpose tables are summary tables. They are also known as analytical tables. These tables are used to indicate the relationship which is of special significance. 3. Original and derivative table. Original tables consists of the original data initially collected from the original source. Derivative table consists of the descriptive measures like average, coefficients, etc. For example, a table formed out of time series data is an original table, while the table of trend values is a derivative table. While constructing a table, the following points should be kept in mind. 1. Table should be attractive, neat, compact and self-explanatory. 2. Table should not be overloaded. 3. Use of abbreviations should be minimized. 4. Use of ditto marks are to be avoided. 5. Arrange data in a table so as it makes the comparison easy. 6. As far as possible, round off the figures in a table. Now, let us summarize the session. This module introduces the idea of classification and tabulation of collected data. At first, objectives, properties and various types of classification are considered. Concept of frequency distribution and construction of frequency distribution are discussed. The idea of tabulation along with objectives, components and various types of tabulation techniques are also narrated. Before we move to the next session, please try to answer the following questions. Question 1. The following data shows the duration of slept in hours of 25 patients following administration of a certain anesthetic. Represent the data in a frequency distribution. 2, 3, 4, 3, 4, 5, 6, 1, 2, 1, 1, 3, 5, 7, 5, 4, 3, 4, 4, 3, 2, 3, 2, 4, 3, 3, 2, 1, 2, 3. Question 2. For the following data given in a grouped frequency distribution, construct 1. Relative frequency distribution, 2. Cumulative frequency distribution. Classes 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. Corresponding frequencies 5, 8, 13, 24, 12 and 8. Question 3. Collect the age, serum cholesterol and blood pressure of patients admitted in cardiology department of a hospital and tabulate the data considering the sex of the patients also. The books for your reference are 1. Marcelo Pagano and Kimberly Guerrio, Principles of Biostatistics, Signage Learning. 2. Mehdi J. Statistical Methods and Introductory Text, New Age International Private Limited. 3. Bud B.R., Sri Venkatramana T. and Madhav Rao K.S. Statistics, a Beginner's Test, New Age International Private Limited. 4. Gupta S.C. and V.K. Kapoor, Fundamentals of Mathematical Statistics, Sultan Chand and Sons. 5. Daniel W. Biostatistics, John Wiley Sons. Hope you enjoyed this session. See you next time. Until then, goodbye.